This is part 4 of the 5-part AudioGuide tutorial series, and I'll be speaking to you today about layering and polyphony in AudioGuide. So we're going to start by using a relatively simple options file, and I'm going to do my best to use this single options file throughout this video with very few changes to most of the important variables that we've talked about thus far in the tutorial series. Today we'll be focusing almost entirely on the superimpose variable, which is the fourth important ingredient that every AG concatenate options file should have. And this is the variable where you specify information about how densely corpus sounds may be selected to approximate the segments of the target sound file. I say the fourth key ingredient of the AG concatenate options file because essentially in this tutorial we've covered in sequence the first three important variables. We've covered the target sound file variable. In the second half of the first tutorial video, we discussed corpus in video 2. Search was our subject for video 3. And now with video 4, we're going to talk in depth about superimpose and the options that are available to you to do different kinds of concatenations with wildly different densities. So before I talk to you about the superimpose variable and the different kinds of keyword arguments you can give it to parameterize the density you get as the output of the AudioGuide concatenate script, I want to start by just talking briefly about each of the core elements of this options file so you have a sense of the materials we're working with in this concatenation. For the target, it's our old friend John Cage, the sound file that comes in the distribution, a short excerpt of speech.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
For the corpus, we're using a sound file resource I haven't shown yet in the tutorial series. It is comes from some recordings I made playing really short notes on the piano. And it is a directory of samples that are pre-segmented into individual sound files. And you can see I've got different pitches, and each of these different pitches has a variety of different dynamics. And these pitches span more or less the entire range of the keyboard, except for the really high notes on the piano that don't have dampers on them, that ring. And I'll talk a little bit more about some issues with this corpus resource and a few things that I'm going to do to fix those issues a little bit later. But this is what we're going to be using for our corpus. Now, me picking a pitched resource for this video is not incidental. When you really densely layer sounds, different kinds of sound resources are more or less intelligible in really dense kind of situations. Pitched resources, sounds that have clear pitches, stable pitches, we are really good at hearing, lots of pitches simultaneously and hearing differences between one chord and another. This isn't so true if I were to use the Lokomon database. It's much harder to mix lots of noise sounds together and get a sense of the contribution of individual components. With the piano database, we're going to hear really clearly the layering because our ears are really finely tuned towards the superimposition of pitch. So that's what we'll be using for this video for the corpus. The search is going to stay the same for the entire video, and it is one that is also relatively simple. Closest percent of corpus segments, the closest 10% by averaged amplitude, and then we're going to pick our winning corpus segment according to average centroid. Again, to just quickly rehash something I talked about in the third tutorial video, we are using averaged descriptors here, centroid seg rather than just centroid, because our corpus resource is static. It doesn't have a meaningful or dramatic morphological change within each sound segment. They are static percussive units, and therefore we're going to use the averaged measurement of descriptors because it'll give us better matching. So even though John Cage's voice is dynamic in terms of its morphology, because the corpus is not, I sort of think that means it makes more sense to use average descriptor values, which is what we do here in search. And then our final variable, of course, is superimpose. And I want to open the documentation for AudioGuide's superimpose variable quickly to give you a sense of what's there. So in documentation, you'll see there's a section for the superimposed variable here. It is set to an object in AudioGuide called SI, and SI has about 8 different optional keyword arguments. SI, the superimposed object, acts as a global density controller for AudioGuide, limiting how many corpus segments can be picked for each target segment, and also enforcing sometimes minimum numbers of corpus segments that must be picked to fit a target segment. I'll talk about all of that in a moment. I want to start with what I think is probably the simplest and more straightforward example of using superimpose in AudioGuide, which is using the keyword max segment in the superimposed variable and setting that to 1. What max segment does is that it restricts how many corpus sounds can be picked for each target segment. It's relatively straightforward. You set this to a number, and this will limit the number of corpus sounds that can be picked for every fragment of John's voice. So I want to start just by running this concatenation with what I think is the simplest superimposition setting, essentially a 1-for-1. One target segment gets one corpus segment, and that's it. So here's how this sounds. You'll hear both the target sound file and the corpus selections at the same time in the sound file because I've got csound channel render method set to target output mix.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
In addition to listening to the sound file outputs in this video, we're also going to look at the output that AudioGuide creates for Bach roll and max MSP. This is something I'm going to cover in a good amount of detail in the next video, video 5, where I talk about the different output formats in AudioGuide and how you can manipulate them. And so I'm not going to talk too much about how this works. All I'll say is that there is a patch in the distribution max MSP folder, the Bach folder. There's a patch called AG playback. And by default, AudioGuide will make a Bach roll input file for every concatenation that you run. In the output folder, it's called by default bachroll.txt. If we load that into this patch, you will see a representation of the segments from the target that we just heard, as well as all the selections from the corpus that we just heard. And I'm able to play those individual notes by highlighting them and pressing V.
The lecture is so soon.
For the target, as well as for the corpus. So this gives you a visualization of the selections, and I think makes it even more clear that we're getting sort of one corpus selection for every target segment, again, because we've set max segment to 1. Now, one thing I want to say before I go any further talking about superimpose is that always remember that superimpose, the kind of design of it revolves around the segments of the target. And so sometimes if you want to get more corpus segments, if you want to have a denser concatenation, the answer is to tweak some of these parameters, and I'll talk about that in a second. But another answer or another approach to working with the outcome you get is changing the target's segmentation, right? If we change the target segmentation so the target breaks into more pieces, we will get more selections because there are more target segments to pick from. Here I'm going to change offset rise to be 1.2. These are variables we covered in the first tutorial video, the second part of it. This will lead to more segments for John Cage's voice because we've made the segmentation algorithm more sensitive to the offset. And therefore, we're going to get more selections. Even though max segment is still 1, we'll get more notes picked because we've got more target segments to pick notes. So this video, this concatenation I just ran had 23 picked events. We'll now run this options file again, and you will see more selections now because we've made more segments out of John Cage's voice.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
Okay, so don't forget, superimpose is the global controller of density, but there are other things that affect density and so the rate at which you hear corpus selections. Target segmentation is really critical here too. The other thing I want to say before I get back to talking about superimpose is that, as you've probably noticed, this corpus sound file resource has a problem. Its problem is that when I recorded this years ago, I recorded sounds every minor third in sort of the Kurzweil sampling paradigm. I recorded sounds every minor third with the idea that you could transpose pitches up either up a half step or down a half step and get the full equal tempered spectrum of pitches. But of course, for AudioGuide, this means that using this as a sound file resource, we're only getting one big full diminished chord the whole time, essentially. So a way around that I'll propose for this video is using the trans method CSF argument. Here we can set a random transposition for each sound in the corpus, and I'm going to assign that random transposition, it's in semitones between -1 and 1. I'm also going to assign the transposition quantize or transquantize keyword argument of CSF to 1. This will essentially give us the full spectrum of pitches, albeit randomly assigned, for this CSF object. So we've got a complete equal tempered spectrum to work with. I'm just going to rerun this quickly.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
Okay, so this is our first important controller, max segment equals 1. As you can probably imagine, you can set this to any integer and get more selections.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
You probably heard that some of those selected segments were chords, meaning it picked 2 corpus segments to happen at the same time to represent a segment of John Cage's voice. At other times, they were staggered in time. I'm going to talk about why that is and how to control that in a little bit. But for now, I'm just going to leave it and say that the most important, probably global controller you have, the most consequential one, is max segment. There's a second one called max overlap. Max overlap also dictates a maximum number of sounds from the corpus that may be picked for every target segment. But instead of specifying it in sort of the total number for each target segment, max overlap says the total number of overlapping sounds that may be picked from the corpus at any given time gets limited by this integer. So imagine we've got a target segment here. I've drawn an amplitude envelope here. This is the amplitude profile of a single target segment. Let's say it's half a second long. And AudioGuide picks a piano sound to represent the first, let's say, half of that segment. If you set overlap, max overlaps equals 1, you are not going to let AudioGuide pick another segment at the start of this note because it's already picked one. However, you are going to let AudioGuide, if there's time left, pick a second note after this first corpus note has expired. So max overlaps, unlike max segment, which restricts how many notes can be picked for this entire corpus segment, max overlap lets you specify a total density based on the durations of the corpus sounds that have been picked. So let's try this script again. We're going to set max overlap equals 1 this time.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
Okay, so max segment, max overlap. The final limiting variable you can use for density in the superimpose object is max frame. So to go back to my drawing of a target segment, oops, this is the amplitude profile of our half-second long target segment that AudioGuide is picking corpus segments to fit. And as you can maybe see from what I've drawn here, AudioGuide obviously gets power measurements in windowed values, meaning it gets a time series that is separated by the hop size of the analysis of the descriptors. You can find information and change the hop size in AudioGuide's analysis routine by looking down here at descriptor computation parameters and changing descriptor hop size in seconds. By default, it is a little bit over 10 milliseconds. So each amplitude measurement, each measurement of every descriptor in AudioGuide is going to be taken from the target segment, from the target's amplitude, in this case, every 10 milliseconds. And therefore, each frame of each target sample is 10 milliseconds long from one frame to the next. So max frame lets you specify the maximum number of samples that may be picked for each frame of the target. Here we're going to get a lot more selections because we're not just restricting selection to each segment of the target, but each frame of each segment, which is every 10 milliseconds by default. So let's listen to how this sounds.
The lecture is so soon that I don't think I'll be able to get all 90 stories written.
Okay, so a lot more selections there. We get some outcome, some concatenated sound that sounds much less pointillistic and much more liquid because we're picking many more sounds, in this case to one sound per frame of the target segment as a maximum. Now, you may have been wondering as I'm talking through, I'm going to comment this out just for a moment. You may be wondering as I'm talking through these different superimposed keyword variables, what happens if we leave superimpose blank? And the answer is, if we don't give any arguments, superimpose is going to pick as many samples as it can in the concatenative process. I'm going to run that, we'll listen to it, and then I'm going to talk about what that means, and I'll give you a little bit more information about how AudioGuide determines whether another sound can be picked or not if you don't give it any restrictions at all. Let's just run this options file, this time with no keyword arguments given to the superimpose object. See a lot more selections, sometimes up to even 30 selections per target segment. Okay, so quite a few more selections there. We had a total of 354 piano notes picked, which I think you can see here that the target sound has 30 segments. So on average, we're picking over 10 corpus sounds for every sound of the target. And to explain what's happening here, I need to dive in a little deeper to AudioGuide's selection algorithm. So let's go back to our graph of the amplitudes of a single target segment. So the way AudioGuide works by default is that every sound it picks from the corpus to match a target segment is aware and takes account of any previous sound from the corpus that's been picked to match that segment. So let's pretend we are searching this John Cage half-second segment to find the best corpus segment. We're going to find the best corpus segment according to the things that are written into search. We're going to account for amplitude. We're going to account for centroid averaged. And let's say this is the amplitude of the corpus sound that ends up getting picked, that ends up the winner of this search process. What AudioGuide does to pick a second sound is it looks at the amplitude of the corpus sound that's been picked, and it subtracts it from the amplitude of the target sound file. This gives a kind of residual spectrum or residual amplitude time varying series for the target, which essentially is trying to account for the amplitude, at least, of the sound that has already been picked. What AudioGuide does next is it says, okay, I've picked one sound, I'm going to subtract the corpus amplitude from the target amplitude, and then I'm going to look at the target amplitude again. I'm going to use these same segmentation parameters, and I'm going to see if there is enough loudness left in the target that needs to be represented so that I should pick another segment. So it'll start in the first frame, and depending on what your threshold is, maybe it will get to here in the target's residual loudness spectrum before it decides, okay, I've got to pick another sound here. It's then going to look at the average centroid of the part of the sound that remains and pick a corpus sound to fit that remaining sound. So it's going to use the amplitude of any target sound, corpus sound that's already been selected to essentially create a residual amplitude graph for the target and do segmentation again. Every time a selection happens for the same corpus segment, it's doing this process, subtracting the amplitude of the selected corpus sound and then looking through the target's residual amplitude and finding the moment, if it exists, that it should start a new sample based on your segmentation parameters for the target. So when we don't give any arguments to superimpose, it is just letting AudioGuide run free. It's saying, okay, you should pick as many corpus sounds from the target until the energy of the residual amplitude of the target gets low enough that there are no longer any sounds to pick. This means different values of the target segment threshold will affect how many sounds from the corpus get picked in this scenario, because the higher you make the threshold, the less likely it is to pick sounds, and you'll get less dense results. It also means that the amplitude of your target and the amplitude of your corpus are important here. If you have a really loud target and a really soft corpus, you are going to pick more sounds in this scenario where you don't have any limits, you don't have any maximums for superimpose, because you're letting the algorithm run free and pick as many sounds as it needs to get that target amplitude low enough so that it no longer triggers selections. So just to show you what I mean, let's run this same options file I just ran again. Again, this is with no superimpose arguments. Therefore, we're just using amplitude subtraction to decide when to stop. It's probably becoming clear why this options file is called Oblinger. But what I want to do now is I want to turn down the volume of the corpus. I'm going to do this using ScaleDB. Remember, ScaleDB is the corpus keyword that makes corpus sound softer. And this not only affects the amplitude of the sounds that you hear in the output sound file, it's also going to affect how loud the corpus sound is in this subtractive representation, such that we're going to pick even more corpus sounds now to fit the target, because we've got softer corpus sounds internally in the algorithm, and we're not giving any limits on how many sounds can be picked per segment or per overlap or per frame. So we had 350 selections last time. Now with ScaleDB minus 12, we're going to get more. I'm not sure exactly how many, but it's going to be quite a bit more, quite a bit denser than we had before. You can see that the concatenation actually gives you information as it's churning about where it's searching and how many sounds it's picked. We're up to 30 now per segment, and we're still going. Up to 50 or 60 per segment. Some are now splitting into the hundreds of piano sounds picked per John Cage segment. It's a context where it's nice not to work in real time. So you can see in total we picked 2,700 corpus sounds to fit John Cage's 30 segments. So quite a few. So because we've turned down the amplitude of the corpus so that it subtracts a smaller amount when sounds are picked from the target amplitude, and we've given no restrictions to superimpose, no maximum segment, maximum frame, maximum overlap, we get sort of outlandishly dense results here. Which almost come close to having almost like every sample, every segment, some different configuration, almost like 50% of all the corpus sounds are being used at every moment, a different 50% to represent the target, which is really, really quite interesting. You can see here why the meaning perceptually of using a pitched resource for this video, because you can hear so clearly the layering of the piano sounds in this context. The Bach roll output becomes a little bit silly, but gives you still some information about the selections that are happening. You can see there's some interesting trajectories and pitches that are getting chosen, especially at the end here, that are visible. And so that's a quick overview of this subtractive amplitude algorithm, which is at the heart of multiple overlapping selections in AudioGuide that the superimpose variable governs. If you don't give it any keyword arguments, nothing is governing it. Okay, so I want to now spend a little bit of time and talk about a few other important things. The first is that I turned down the amplitude of the corpus with ScaleDB, which made more selections because corpus sounds internally are thought of as being softer, and therefore more of them are needed to represent the amplitude of John's voice. Instead of doing that with ScaleDB, there's also a keyword argument for superimpose called subtract scale. This will multiply the amplitudes of the selected corpus segments by a number so that they are more or less effectual when being subtracted from the target. So if we set this to 2, corpus sounds are going to be, the amplitudes are going to be multiplied times 2 before this subtraction happens, and therefore the subtraction is going to be more decisive. So we had 300 some events, I think, before. Now we've only got 179 because we've turned up the volume of the corpus sounds. Again, just internally in this kind of algorithm, we've turned up their volume so that they take away more of the target's amplitude, and therefore the segmentation, the algorithm moves on more rapidly through the target, through the corpus segments. So obviously you can get really sparse results this way too. If I were to make a really large subtract scale, we're going to get now just one corpus segment per one target segment. Here we'll do 10. So that's subtract scale, which lets you do the same kind of thing I was doing here with scale dB, but it doesn't change the volume of the corpus sounds in the output rendering. It only does it internally in this superimposition calculation algorithm that AudioGuide does to layer sounds. Now, I've talked about max segment, I've talked about max overlap, and I've talked about max frame. I should also note that each one of those 3 keyword arguments has a twin which doesn't specify a maximum but enforces a minimum. So if I were to instead write writing max segment, write min segment, this would tell AudioGuide that for each segment of John's voice, it must pick at minimum 10 segments. Now this in some way overrides the subtractive amplitude algorithm I just talked about. Remember, the subtractive amplitude model says every time we pick a corpus sound, we decimate, we make softer the internal representation of the amplitude of each cage segment. If you use one of these minimum arguments, you are going to say, no, I don't care about the subtractive algorithm. I want you to override that, and you must pick 10 sounds, even if the amplitude, the residual amplitude of each target segment doesn't merit it. So here we're going to get 10 sounds minimum for each target segment. There's no maximum, there's only a minimum. And it's really often effective to chain these things together. If you, for instance, give both a value for minimum segment and maximum segment, here I'm going to force the algorithm to pick at least 10 segments from the corpus to fit John's voice, each segment of that. But I'm also going to cap that number at 10 as well. This will assure us that each segment of John Cage's voice gets 10 piano sounds, regardless of whether the subtractive amplitude model merits it or not. Okay, so you have the minimum gives you a way to essentially enforce that the algorithm is going to have to pick a certain number of things, even if it doesn't want to. And maximum and minimum used together will give you certain chords that happen every time with a certain number of voices dependably. There's one final thing I want to say about this configuration, the max segment equals 10 as well as the min segment equals 10. And that is there's one final keyword argument I want to mention for superimpose, and that is calc method. Calc method lets you turn on or off different parts of AudioGuide's superimposition algorithm. By default, calc method is set to mixture. This will do what I've talked about already. It will pick a corpus sound. It will do the amplitude subtraction to obtain the residual spectrum of amplitude for the target to make further selections. And it will also, mixture will also do something really important for AudioGuide, which I haven't mentioned in the tutorial series. It's a little bit technical. It will try to account for the previous selected sounds. It will try to account for their descriptors, such that when it's looking for the best average centroid, it's going to look at the average centroid of the target and the average centroid of all the corpus sounds that have already been picked, plus all the possible sounds that might still be picked. So it's mixing descriptor values together. And the idea is that, and this is what AudioGuide does by default, descriptors, the sum of all the descriptors that are, of all the sounds that are picked happening simultaneously, the idea is that it's trying to approach that target descriptor value in your target sound file. You can turn this off by setting calc method equals subtract. This is only going to do subtraction part of this algorithm, but not do the descriptor mixture part. You'll get different results as a consequence. You can also set calc method to none. And this is going to essentially turn off all of the overlap calculations for the superimposition object and essentially make it so that every time a corpus sound is picked, it has no knowledge of any previous corpus sound selection, meaning there's no subtractive amplitude model changing the dynamics of this subsequently selected sounds. There's no descriptor mixture model. This essentially turns all of that off and does concatenative synthesis as if each sound selection is its own island that knows nothing about other sounds around it, before it or after it, that have been picked already. You hear this is much more uniform. Earlier versions of this algorithm were picking, after it had picked one corpus sound, when it picked the second one, it was trying to mix their descriptors together to approximate the target, so we get more variability within the corpus. Here you can hear they're much more focused on certain pitch bands, much more focused on certain timbres and dynamics than they were before, and that's because we've turned off not only amplitude subtraction, but the mixture algorithm as well. Okay, I want to talk now about min frame. Min frame is just like max frame in the sense that it limits the number, it deals with the number of selections that are possible for every frame of the target's analysis. Here, instead of enforcing a maximum, it's going to enforce a minimum, meaning for every frame of the target, we must pick at least one sound. I'm also going to specify max frame here, like we did in the previous example. I'm going to remove calc method for a second, but I'm going to come back to it in this example. So here, we're essentially saying every moment of each target segment must have one corpus selection, but it only can have a maximum of one selection. We'll get something much more fluid, stream-like sound from the corpus in this context, rather than something which is more sounds more like chords, like we got in the previous concatenation. So amplitude subtraction is happening here and mixture is happening here. And you might notice that you kind of hear a low sound first and then you hear piano notes go up into the high register after an initial attack. That's in part an artifact of the descriptor mixture algorithm. Here I'm going to turn that off. And so it's going to pick one corpus sound for every frame, for every analysis frame of each segment of John Cage, like before, except it's going to do it in a way that doesn't account for previous selections and the sounds that were picked before it. So we won't get this effect of having kind of a low note that then's followed by some high stuff that's coming from the descriptor mixture algorithm. We're now turning that off. We're also turning off subtraction. And we're going to get something that's a lot more like mosaicing, where you're just picking one sound for every frame and not caring about what's already been picked or what's going to be picked in the future. So there are advantages and disadvantages to both approach. Turning off the calc method lets you get this much more fluid stream-like concatenation, which is interesting. having mixture and envelope subtraction on, the default where it's set to mixture, will give you results that help approximate sort of timbre and descriptors in a much more reasonable way, especially if you've got vertical harmonies you're trying to make, vertical stacking of sounds. I want to talk about one more configuration of these parameters, and then I'm going to move on to talking about some corpus level things you can do with density, restrictions you can make. And the final thing I want to say is that you can also, another interesting configuration of these keyword arguments is combining min frame and max segment set to the same value. So what this tells the algorithm is it says, for every frame of the target segment, you must pick at least 6 sounds. Sounds like a lot. But it's also then specifying that for every target segment in total, it can only pick 6 sounds. Max segment always wins over frame. And effectively what this is going to do is force the algorithm to pick 6 sounds at the very beginning of each target segment. And then it's not going to be able to pick any more because it's reached the max seg limit. And so effectively this will make make the corpus form chords in the target that are vertically stratified, that all the notes start together. There's not going to be, like smears of notes because you're forcing it to pick 6 sounds on the first frame, and then you've filled up your max segment selections and you're going to move on to the next segment after that. So the final thing I want to say here is that so far we've looked at superimposed keyword arguments, and again, I've told you that these are global controls. They look at the superimposition of sounds from the corpus and don't distinguish anything about what corpus index they come from. You could have a corpus with many different sound resources in it, and superimpose isn't going to care about which sound resources are being picked. It's only going to care about a kind of the global totals of the frames and the segments and the overlaps of corpus sound. However, there are some corpus level controls you should know about. So I'm going to go back to, actually, let's go back to where we were. This max and min frame equals 1 with the calc method turned off. I'm going to add now another index for our corpus. It's going to be a folder of Crotale sounds, which is from Vienna Sound File Library, I'm pretty sure. All normalized to -3 dB, so we'll use the file name dynamic like we talked about in the first video, using whole file equals true. And I want to just run a concatenation first with these 2 resources. Again, there's no temporal restrictions in the corpus at the moment, and so superimpose is going to govern density, and it's not going to care about whether we're dealing with piano sounds that have been picked or Crotale sounds. See now our Bach roll will have a new voice for the Crotale, which is very high. Okay, so while the global controls are really useful in creating something more rarefied if you want, they don't let you access individual members of the corpus to restrict them. And there's a couple of keywords that are part of the corpus sound file object. I'm just going to open the documentation to show you what I'm talking about in the docs. So if you go to, where is it? The corpus variable. Oops, here it is. You'll see that this is the CSF object is the one with this huge list of parameters. And 2 of them I'm going to be talking about now are restrict in time and restrict overlaps. Restrict in time acts as a density limiter only for this corpus entry. And it essentially poses the restriction, this corpus resource can only be used every X seconds. In this case, 1 will say that we're only allowed to pick a sustained Crotale sound every second, regardless of superimpose. This essentially turns off this corpus resource if this criteria is met. So let's run this again with restrict in time equals 1. Okay, so you can see and hear the difference here. Now the piano is allowed to go wild, and the crotales are restricted in terms of the selections at the corpus level. Another parameter that's interesting to think about is restrict overlaps. This works a lot like restrict overlaps did in the superimpose keyword, the min and max overlaps arguments. Here you can specify them at the corpus level. So you're again restricting the density, this time according to the overlapping durations of the selected corpus sounds just for this corpus entry. So that's all I really have to say about the superimposed object and its keyword arguments. There's more detail in the documentation and a few examples for that supplement some of the things I've already given you in this tutorial. I know this tutorial has been a little bit technical. All this talk about amplitude subtraction and descriptor mixture is a little bit much, but I hope it's worth it in the sense that by understanding a little bit about how AudioGuide works internally and manipulating these parameters accordingly, you can get a huge continuum of really sparse concatenations versus like bombastically dense concatenations, something that I think is a real strength and selling point for non-real-time concatenative synthesis. So that's all for this video. In the next video, I will talk about output files. I'll talk a little bit about the different kinds of output files AudioGuide can make. I'll talk about the ways you can work with them and parameterize them to integrate AudioGuide's output into your workflow. And I will be talking more in depth about this Bach roll output to give you a sense for some of the possibilities and ways that you could work with this. A final note I want to say about that before I go is that it is the case, as you might be suspecting, that you can use AudioGuide to write for acoustic instruments, which is to say make musical scores, rather than just make electronic music or make concatenations of sound files. It does use this Bach roll interface as its default mode of working. And I'll be making a supplemental video to the tutorial about working with AudioGuide in that writing for instruments context. So please do go check out the tutorial page. Down below the 5-part series, there'll be some supplemental tutorials where I'll talk about that topic and some others that might interest you related to AudioGuide and concatenative synthesis.